Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we have been provided with a 3D isometric projection of an engineering object into which the front view face, the top view face and the right hand side view face of the solid has been combined into a single 3D isometric projection view over here. So using the information available with us into this 3D isometric projection, we are required to evaluate the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections of the solid. So in order to evaluate the orthographic projections of the solid, so we need to determine the dimensions of the front view face, the top view face and the right hand side view face corresponding to the solid. As we look at the solid from the front view orientation, so we observe that the width of the solid happens to be equal to 89 millimeter, while the height of the solid happens to be equal to 35 millimeter. So the dimensions of the front view face corresponding to the solid will be measuring 89 millimeter by 35 millimeter. When we are going to look at the solid from the top view orientation, so we observe that the width of the solid, it is equal to 89 millimeter, while the depth of the solid, it happens to be equal to 32 millimeter over here. So the dimensions of the top view face of the solid will be measuring 89 millimeter by 32 millimeter. And when we are going to observe the solid from the right hand side view orientation, so we observe that the depth of the solid happens to be equal to 32 millimeter, while the height of the solid, it is equal to 35 millimeter. So the right hand side view face of the solid will be measuring 32 millimeter by 35 millimeter. So with this information, we are required to evaluate the orthographic projections of the solid over here. So now we are going to draw the XY reference line, the X1, Y1 reference line, and we have also drawn a transfer line which is originating from the intersection point corresponding to the XY reference line and the X1, Y1 reference line. And this transfer line has been drawn at an angle of 45 degree with respect to the XY reference line. And we are going to use this transfer line in order to transfer the distances into the top view projections alongside the depth of the solid into the right hand side view projections over here. And now since we are going to obtain the orthographic projections of the solid into the first angle projections, so we will be obtaining the front view projections corresponding to the solid above the XY reference line. The top view projections of the solid will be obtained below the XY reference line, while the right hand side view projections of the solid, they will be obtained on the left hand side of the front view projections above the XY reference line. So now we know that the front view face of the solid, it will be having the dimensions equal to 89 millimeter width of the solid and 35 millimeter height of the solid. So now we have marked this width of the solid into the front view projections over here by drawing two vertical projector lines into the front view projections such that the distance between these two vertical projectors will be equal to 89 millimeter. And we have extended these two vertical projector lines from the front view projections into the top view projections over here, because into the top view projections as well we are going to require the width of the solid, it is equal to 89 millimeter. Now we also know that the height of the solid, it happens to be equal to 35 millimeter. So we have marked this height of the solid is equal to 35 millimeter into the elevation view or the front view projections by drawing a horizontal projector line at a distance of 35 millimeter from the XY reference line. And this horizontal projector line we have appropriately extended into the right hand side view projections over here, because into the right hand side view projections also we are going to require height of solid, it is equal to 35 millimeter. Next we have got the top view projections corresponding to the solid. So into the top view face, we know that the dimensions of the top view face will be 89 millimeter width of the solid and 32 millimeter depth of the solid. So 89 millimeter width of the solid we have already obtained. Now we have to draw two horizontal projector lines which will be separated by this distance of depth of the solid is equal to 32 millimeter. And these two horizontal projector lines we have appropriately transferred into the right hand side view projection view using this transfer line over here, such that we are able to obtain the depth of the solid equal to 32 millimeter into the right hand side view projections over here. So this way we have been able to complete the right hand side view face corresponding to this solid also, which is mirroring 32 millimeter depth of the solid, 35 millimeter height of the solid over here. So this way we have been able to obtain the front view face projections, the top view face projections, and the right hand side view face projections over here. Now we are going to divide this solid into multiple elements, and those elements projections we are going to obtain into the front view, top view, and the right hand side view projections over here. So now we can see we can easily divide this solid into three elements. So first element happens to be a horizontal wave which is lying onto the base of the solid, and it is carrying a circular hole at the center of this particular element number 1 over here. Whereas element number 2, it happens to be an inclined web over here, which is going to connect the horizontal web at the bottom with horizontal web which is lying at the top surface of the solid, which we are going to refer to as element number 3. And now we have got the element number 3 horizontal wave, which is a horizontal block which is lying at the top surface of the solid, and this horizontal web at the top, it is carrying a rectangular slot onto the right hand side portion of the solid over here. Let us start with construction of orthographic projections of the solid. So now we can check, we have been provided with the location of this particular point over here into the isometric projection, that is the distance of this point corresponding to the left hand side face. It is going to be located at a distance of 38 millimeter from the left hand side face of the solid over here. So now from the left hand side face of the solid at a distance of 38 millimeter, we have obtained a vertical projector line which is going to depict the location of this point over here, right? So now we have marked a vertical projector line at a distance of 38 millimeter from the left hand side face of the solid, and we have extended this vertical projector line into the top view projections as well. Next we have got the location of this point corresponding to the element number 2 over here. This was the first point corresponding to element number 2. Now this is the second point which is lying at the base corresponding to element number 2 over here, which happens to be an inclined web Now corresponding to this point number 2, we know that point number 2 will be located at a distance of 41 millimeter from the right hand side face of the solid. We are going to mark a distance of 41 millimeter as we are going to move along the base of the solid towards the left hand side over here. So point number 2 will be located onto the base of the solid over here. So next we are going to locate the thickness of this horizontal web, which happens to be our element number 1. So we know that element number 1, it is a horizontal block which is located at the base of the solid, and the height of this horizontal web happens to be equal to 12.5 millimeter. So now into the front view projections, we have marked a distance of 12.5 millimeter from the base, and we have obtained a horizontal projector line into the front view projections at a distance of 12.5 millimeter from the base of the solid, and we have extended this horizontal projector line into the right hand side view projections over here. So now we can check at a distance of 38 millimeter from the left hand side face at a height of 12.5 millimeter from the ground. So this point number 1 we can appropriately locate into the front view projection. So the 2 points, point number 1, point number 2, we have been able to locate into the front view projections corresponding to this inclined web, which is going to connect horizontal web element number 1 and the horizontal web element number 2 over here. Now next we have got the information that corresponding to this element number 3, which happens to be again another horizontal wave which is lying at the top face of the solid over here. So the thickness or the height of this element number 3 or the horizontal web at the top surface of the solid, it happens to be equal to 12.5 millimeter. So now we have obtained a horizontal projector line at a distance of 12.5 millimeter from the top surface of the solid into the front view projections, and this horizontal projector line we have extended it into the right hand side view projections over here. Next we know that corresponding to this top surface horizontal web, so there are 2 points corresponding to the element number 2, that is the inclined web, which are to be located over here into the front view projection. So now we know that at a distance of 12.5 millimeter from the top surface and at a distance of 35 millimeter from the right hand side face of the solid, so we will be able to locate this point number 3 into the front view elevation projections over here. So now we can check at a distance of 12.5 millimeter below the top surface of the solid and at a distance of 35 millimeter from the right hand side face of the solid. So this point we can locate over here. This is going to be our point number 3 corresponding to this inclined web. So this way we have been able to obtain a vertical projector line at a distance of 35 millimeter from the right hand side face of the solid into the front view projection. And once again we have extended this vertical projector line into the top view projections as well. Next we have got this point or this point. Now let us evaluate the location of this point into the orthographic projections. Now we have been provided with the information that from the right hand side face of the solid, the distance of this edge point or this edge point from the right hand side face, it happens to be equal to 45 millimeter. So now what we have done, we are going to mark a distance of 45 millimeter from the right hand side face of the solid, and we are going to obtain a vertical projector line at a distance of 45 millimeter from the right hand side face and one vertical projector line we have drawn over here, and this vertical projector line we have extended appropriately into the top view projections as well. And now we know that this point will be lying onto the top surface of the solid. So onto the top surface of the solid. Now point number 4 corresponding to this inclined web has been located using the coordinates available with us through this isometric 3D projection view over here. So now we have been able to obtain all these 4 points. Now we can join point number 2 with point number 3, point number 1 with point number 4. It can be joined. And another thing we know over here, now this is going to be our horizontal web. On the bottom, this is going to be our horizontal web at the top over here. Another information is available with us regarding this horizontal web at the top. What is that information? There is a rectangular slot which is provided onto this horizontal web which is available onto the top surface of the solid. How do we locate this rectangular slot? So we know that the distance of this slot edge from this particular edge over here of the isometric projection, it happens to be equal to 25 millimeter. So from this point which we have already located, now we are going to mark a distance of 25 millimeter towards the right hand side surface of the solid. So from this point we are going to move towards the right hand side surface by a distance of 25 millimeter. So that now we know that the width of the slot, it will be equal to 20 millimeter because this total length of the horizontal web happens to be 45 millimeter. So from this point, that is 45 millimeter point, we have moved a distance of 25 millimeter towards the right hand side, and another vertical projector line we have obtained corresponding to this surface of the slot over here into the front view projections, and this vertical projector line we have extended it into the top view projections as well. So this way this slot has been located into the front view projections over here. Now we also know that the horizontal web, which is our element number 1, which is lying at the base of the solid, it is carrying a circular hole over here. So now what we have to do, we have to locate the center point corresponding to the circular hole over here, and we know that the center of the circle, it is located at a distance of 19 millimeter from the left hand side face of the solid. We have marked a center line at a distance of 19 millimeter from the left side face of the solid, and this vertical center projector line we have extended it into the top view projections as well. And now, having identified the location of the center line with respect to the left hand side surface of the solid, now we know that the diameter of the circular hole or the circular slot into this base horizontal web, it happens to be equal to 16 millimeter. So from the center line, we'll take an offset of 8 millimeter on either side. So 8 millimeter onto the left side, 8 millimeter onto the right side, and two vertical projector lines we are going to draw into the front view projections, which are separated by the distance 16 millimeter. And these two vertical projector lines we have extended into the top view projections as well. So let us start joining the edges using the object lines which are visible to the observer. So we know that this Z shape, so this shape of the object is visible to the observer, and the observer is going to look at the solid from the front view orientation. So as the observer will be viewing the solid from this orientation, so the true shape projections corresponding to this surface, which will be corresponding to element 1, element 2 and element 3. So the true shape projections of this surface will be obtained onto the vertical plane, because this surface happens to be parallel to vertical plane. Now we also know that there is a rectangular slot which has been cut into the top surface horizontal web over here, and this slot is having the dimensions: width it is equal to 20 millimeter, height it is equal to 12.5 millimeter. So we can check corresponding to the slot, which is once again parallel to the vertical plane, the true shape projections corresponding to the slot measuring 20 millimeter width and 12.5 millimeter height, they have been obtained into the front view projections over here. So since this surface is not visible to the observer from the front view orientation, so we are going to obtain hidden line projections corresponding to this vertical surface of the rectangular slot over here. Next, we also know that this circular hole, it will also not be visible to the observer, as the observer is going to look at the solid from the front view orientation. So we are going to obtain the hidden line or the dotted line projections into the front view, so that we are able to obtain the apparent shape projections corresponding to the circular hole into the front view projections over here. So these rectangular projections will be the apparent shape projections corresponding to the circular hole over here. Now let us proceed to evaluate the top view projections corresponding to the solid. Now as the observer is going to look at the solid from the top, so we observe that this rectangular hole, it is located centrally onto this top surface web over here. Similarly, this circular hole, it is also located centrally onto this element number 1, which is a horizontal web which is available at the base over here. So we know that this distance happens to be 16 millimeters from the rear face of the solid. So now from the rear face of the solid, we have marked a distance of 16 millimeter, and we have obtained a horizontal central line into the top view projections, and this horizontal central line, we have appropriately extended it into the right hand side view projections using this transfer line over here. So now we have been able to obtain the center point of the hole and the center corresponding to this rectangular slot over here into the top view projection. Now we know that this depth of this particular surface from the rear surface of the solid, it happens to be equal to 10 millimeter. So this depth corresponding to the square block over here, it happens to be equal to 10 millimeter. So now from the rear face of the solid, we have marked a distance of 10 millimeter, and we have drawn a horizontal projector line into the top view projections, and we have transferred this horizontal projection into the right hand side view projection over here. Similarly, from the front face also we can observe this surface, it is having depth equal to 10 millimeter. So corresponding to this top surface horizontal wave, now we are going to mark a distance of 10 millimeter from the front face of the solid. This is the front face of the solid. So from front face, we have marked a distance of 10 millimeter, and we have drawn a horizontal projector line into the top view projections, and we have transferred this projection line using this transfer line into the right hand side view projections over here. So now we know that this is the center point for the circular hole. We can check this is the center line at a distance of 19 millimeter from the left hand side face, and at the center of this horizontal base block over here. So this will be the location of the center point. Now we know that the diameter happens to be 16 millimeter. So with a radius of 8 millimeter or diameter of 16 millimeter, we have been able to obtain the top view projections corresponding to the circular hole into the element number 1 over here, and we have been able to obtain the true shape projections corresponding to the circular hole over here. Next, we know that corresponding to this circular hole, we can draw two horizontal projector lines into the top view projections, and these two horizontal projector lines we need to extend into the right hand side view projections over here, because we know that when we are going to look at the solid from the right hand side, so we need to acquire information about these two diameter end points corresponding to the circular slot. So this information we have been able to obtain over here. So these are two end points of the diameter corresponding to the circular hole into the right hand side view projections over here. Now let us start joining various edges which are visible to the observer. So as the observer is going to look at the solid from the top, so this top surface of the element number 1, which happens to be a rectangular surface, it will be visible to the observer. So since this surface happens to be parallel to the horizontal plane, so the true shape projections corresponding to this horizontal web top surface will be available into the top view projections over here. Next, we have got this top surface of the element number 3 over here. So corresponding to this element number 3 top surface, so here we have got a rectangular slot and here we have got a flat surface over here. So now we can check, since this top surface corresponding to element number 3, it happens to be parallel to the horizontal plane, so we have been able to obtain the true shape projections corresponding to this top surface of the element number 3. Then we have got this inclined surface over here, whereas corresponding to this inclined rectangular surface, which is inclined with respect to the horizontal plane, we are able to observe a small rectangular apparent shape projections over here into the top view projections. So here we can check that this is a very small apparent shape rectangular projections which we have been able to obtain into the top view because of very steep angle corresponding to this rectangular surface, which is our element number 2 over here. So this way we have been able to obtain the top view projections corresponding to this inclined surface into the top view projections over here. Similarly, we can check that this is another face of this element number 2, which happens to be an inclined rectangular surface once again, but this inclined rectangular surface at the bottom of this inclined element number 2, it is not visible to the observer from the top. So we are going to obtain corresponding to this bottom face of the inclined surface dotted line projections into the top view projections over here. So this surface will be visible to the observer. So that is why we had been able to obtain apparent shape object line projections in the top view projections over here. Whereas this surface, it is not visible to the observer. So that is why we have been able to obtain dotted line or the hidden line projections into the top view projections corresponding to this surface of the solid over here. Now let us obtain the right hand side view projections of the solid. So when we are going to look at the solid from the right hand side, so now we can check corresponding to this element number 3, this surface is visible to the observer, this surface is visible to the observer, and this slot surface, it is also visible to the observer. So corresponding to these 3 surfaces which are parallel to the profile plane, we have been able to obtain the true shape projections into the right hand side view projections over here. Now here we have got an inclined surface over here. So this inclined surface will also be visible to the observer. So now we can check that corresponding to this inclined surface, we are able to obtain the apparent shape projections into the right hand side projections over here. So we can check this rectangular projection. It is smaller projection corresponding to this larger rectangular surface which we are able to obtain corresponding to the bottom face of this inclined element number 2 over here. Now we have also marked a hidden line projection at a distance of 12.5 millimeter above the ground. So this hidden line projection, it is corresponding to the top surface of the bottom horizontal web, which is going to be available at a height of 12.5 millimeter from the ground. So we can check. So this horizontal surface edge view. So total surface will be viewed as an edge view into the right hand side view projections over here. And another information we do have over here, it is corresponding to this circular hole. So this circular hole which is located centrally into this horizontal web number 1, it is not visible to the observer from the right hand side view orientation over here. So now we have already marked the location of the circular hole into the right hand side view projections over here using these two black projection lines. So now the hidden projection lines or the dotted line projection line we have drawn over here corresponding to the circular hole which is available into this element number 1 over here. So this way we have been able to obtain the apparent shape projections corresponding to this circular hole, apparent shape projections corresponding to this inclined surface which is lying over here, again true shape projections corresponding to these three surfaces into the right hand side view projections over here. So this way we have been able to obtain the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections corresponding to this engineering object for which we had been provided with the 3D isometric projection view drawing over here. So this is all for today. We are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lecture classes. So thank you very much. Thanks a lot.